Welcome to Chemistry with Crib. Provided below is a gas discharge tube. Inside of this gas discharge tube is a sample of pure hydrogen. When a sufficient electric current is passed through the hydrogen atoms, that is, when electrons with a sufficient amount of energy is passed through those atoms, the electrons inside of the hydrogen atoms will become excited. In so doing, they absorb energy from the colliding electrons, and the hydrogen's electrons become excited in moving up to higher energy levels. However, they do not remain in this state. In the next moment, they fall back down to their original state, releasing energy in the form of light. Every single wavelength of light that we encounter in the world is emitted from a very specific transition of an electron inside of an atom. It is important to note that energy must be absorbed for electrons to become excited. And the more that electrons are attracted to the nucleus, the more energy is required to excite them. Additionally, energy must be released for electrons to transition to lower energy states. And this energy released corresponds to the energy difference in the electron itself. And this energy released is in the form of the smallest unit of light, called a photon. The electromagnetic spectrum reveals all different types of light that can exist in our world. Lower energy light, like radio waves, carry radio signals all around us. Microwaves carry our cell phone signals to cell towers, and with sufficient intensity can heat up our food. Infrared rays are emitted in the vibrations of atoms and are given off by anything with substantial amounts of heat. Visible light, only a small, tiny part of the spectrum, is related to what our eyes can detect. Ultraviolet has sufficient energy to break chemical bonds. X-rays can go through bodies and allow us to see from the inside out. And gamma rays are emitted from nuclear reactions. It is important to note that the smaller the wavelength of light is, the more frequent and the more energetic that light will be. However, the larger the wavelength of light is, the less frequent that wave occurs and the less energetic that light will be. As we can see from this model of the hydrogen atom's electronic transitions, the higher energy light is associated with larger transitions. That is, higher energy light with a smaller wavelength is associated with an electron transitioning from increasingly more energy levels. However, the energy of the light also increases as an electron transitions to even lower energy levels, corresponding with increased attraction of the electron to the nucleus, with transitions to the third energy level associated with infrared light, and transitions to the second energy level associated with visible light, and transitions to the first energy level associated with UV ultraviolet light. Till next time, Crib.